Today we're going to look at exponents and scientific notation. So here at first we're going to start talking about how to use exponents. The exponent is the number that's placed on the base. So if you have something like this, where you have something raised to the n like that, x is called the base. And n is the exponent. And x to the nth means x multiplied times itself n times. Hopefully that's stuff you already knew, but just in case you didn't. So we're going to talk about simplifying with exponents, and we're going to also talk about scientific notation. So here it's given us an example. The original form was 5 to the second power times 5 to the fifth power. They rewrote that in factored form. And then in simplified form, notice there are 7 5s being multiplied together here, so that's 5 to the 7th power. So for this one, 2 to the second, that'll be 2 times 2, times 2 to the 4th, that'll be 4 2's multiplied together, is 2 to what power then? 2 to the 6th. All right, please do the next two. So hopefully on that, and the only problem with this is how long it takes to write it out. 4, 5, 6, 7 times. So that's 3 to what power? To the 9th power. And here we've got 3 x's multiplied together times 5 x's multiplied together, which give us x to what power here? X to the 8th. All right, on this next one, I wanted to just stop before this one because sometimes students get confused. Here, we've got 3 x's multiplied together times 2 y's multiplied together. So that's going to be x times x times x times y times y. Times, and this is where students sometimes get confused, this squared only applies to what is directly in front of it. So when we say that it's xy squared, how many x's do we have here? Just one. And then how many y's? 2. So when we multiply that all together, we're going to have 4 x's multiplied together, x to the 4th, and 4 y's multiplied together, y to the 4th. Or you can rewrite this as x, y to the 4th, because that would be xy times xy times xy times xy. We'd also have 4 x's multiplied together and 4 y's multiplied together. Notice that I had to put that in parentheses. Say it again louder. Yeah, it applies to that everything. So it's xy times xy times xy. This is why, and I know that you guys have seen these problems before, if I have -2 to, let's say, to the 4th power, Does the 4 apply to the 2? Obviously. Does the 4 apply to the negative? No. This is the opposite of 2 to the 4th. This is negative 16. As opposed to, if I put that negative 2 in parentheses, yeah, it's negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. So an exponent only applies to what is directly in front of it. All right, please go ahead and do the last two if you have not already. Hopefully you got something that looks like this. So what we need to look at is we'd like to be able to go directly from something like this to this. What is that we're doing? And let's not be skimpy with our explanation. Our explanation should include what operation are we doing to start with, what else do we have to notice before we do the last part. Sometimes students only focus on the last part and it gets them in trouble later on. So what is it that we're doing? I'm sorry, I heard simplifying. So yes, we're simplifying. So what is it that we're starting with?
Original form.
Okay, and what do you notice? What are we actually doing?
Combining the exponents.
Now, what are we actually doing? We're multiplying. And we're multiplying two expressions that have,
3.
which is the,
The new rule. The base.
yeah, it says right here
Oh, yeah.
that x is the base. I like that the people that are giggling didn't offer any answers.
Yeah, guys.
Okay? You don't get to laugh at people who are actually trying. So they have to have the same base. And then what is it that we did with the exponents?
Add them.
We added them. So when multiplying, two expressions with the same base, do we change the base? No, what do we do? Pardon? Oh, what do we do to the base? We keep it. Keep the base. And what do we do with the exponents? And add the exponents. So they have to have the same base, and we'll keep the base and add the exponents. So everybody do part B, please, if you haven't already. So Christian, what is it going to be?
20 to the power of 63.
Exactly right. We're multiplying two expressions with the same base. We'll keep the base and add the exponents. All right, what about this one? Notice not everything is quite the same here, but if we just pick out the 3's, it's going to be 3 to what power? 3 to the 4th power, because we have 3 times 3 times 3 times 3. And then what will W's power be? 6. Now, like I see a 3 and I see a 2. Where'd you get 6 from? Pardon?
The other one to the right.
Yeah, what power is that? Exactly right. It's to the 1st power. Do we bother writing that? No. It's a little bit like when we write a variable. Do you very often write, 1x? Most of the time we just write x, because it's understood that that means there's just one of them. Same with the power. We usually don't write to the 1st power because it doesn't change the value. All right, so if you've got a calculator with you, great. If not, use your iPad and multiply these out. So, gentlemen, what did I say to do? Do it. Okay? If you can do it without, that's fine. But if you're turned around talking to people, that's not fine. Johnny? Are you done with them? Pardon? Pardon? Okay. Then either use your iPad or do it without, but either way, please do all of those. So if I was to put a decimal in each one of these, and it's not required, but I think it makes more sense in our explanation, what is it that we're doing? What's happening to the decimal? Moving which direction? To the right. And how many places do we move that decimal? Whatever the exponent is. Okay? Next week we'll look at, well, what happens if the exponent is negative? That way. Which way is that way? To the left, yes. Okay? All right, so go ahead and turn it over. Please go ahead and write out both of these. All right, so Paul, what do you have for A?
7,865 per liter.
Wait a minute, sorry, say it again a little bit slower.
7,865.9.
Thank you, sir. And Barrett, what about this one?
I think I did it wrong. I got. I don't know. Can I just say the numbers? Like
Yeah, and then I'm going to ask you to say it correctly, but say the numbers first.
3, 4, 6, 3, 8, 0, 0, 0.
That's correct. So what is that going to be?
34,638,000.
Perfect. So you did great. So, pretty big number. So now we're going to talk about scientific notation. So if you're measuring something that is really, really, really large, or, we'll talk about this next week, something that is very, very, very small. So like if you're looking at how far away a star is from Earth, well, they're all a long way away. Or in this example, the diameter of the sun, 1,390,000 kilometers. That's a pretty good sized diameter. So frequently, those are written in what's called scientific notation so that you don't have to write all those zeros. So in scientific notation, the diameter of the sun is 1.39 times 10 to the 6 kilometers. So let's write 10 to the 6th as a single number without an exponent. Bless you. So 10 to the 6th, it's pretty easy to remember this. When you're raising 10 to a power, that power tells you, well, if it's positive at least, how many zeros you're going to have. That's going to be a 1 with 6 zeros after it. So that's 1 million. So what happens to 1.39 when you multiply it by this number? What happens?
With this lose 6 spaces to the right.
Yes, exactly right. Well said. The decimal moves 6 places to the right. All right, in scientific notation, the mass of the sun is 1.99 times 10 to the 30th kilograms. Write this as a single number. If you haven't already done that, please write that as a single number. And then we'll see if anyone can come up with the right words for that.
What comes after septillion?
Octillion?
What comes after octillion?
It's 9.
Non-tillion? Nintillion? Non-million?
Did you just say 9 million?
Non-million. I said non-million.
It's a lot of zeros right there.
What comes, does octillion come after a septillion?
I think so.
What comes after octillion?
Nonillion?
Non-million.
You
You said
non-
nontillion.
Yeah, you did say non-tillion.
Oh.
So would it be one non-net? That was close enough. One
So let's see, 1, 2,
Yeah.
so
Would it be 1.999 million?
millions, billions, trillions, quadrillions, quintillions, septillions, octillions,
I
non-millions.
thought it went sextillions, then septillions.
It's a good question. So this is millions, right?
Yeah.
Billions,
Trillions.
trillions. This is what, quadrillions?
Yes. Then quintillions.
Quintillions.
What's six?
Sextillions. I thought it went sextillions and septillions.
Sectillions. And then septillions, or is it heptillions?
I thought it was septillions.
It's probably septillions.
And
This would be octillions,
then, so 1.99 non-million.
non-millions. That doesn't sound right, does it? Yeah, you've got your iPad out. You go, what comes after octillions?
What's 10?
Quadrillions, quintillions, septillions. What?
Nonillion, decillion, nonillion.
So non-million, so decillion is next. So 1 decillion, 990 octillions.
Dang, that's a large number.
Yeah. All right.
Small star.
Only here.
We have a small star.
Well, and you can see from, I think this is a good example. Some of the other ones, like this previous one, it's like, that's not so big that I think you really need to use scientific notation on it. But something like this, you absolutely want to use scientific notation on that, right?
I'm not writing that out.
Yeah.
I'm not writing it out again.
So, here are the rules for scientific notation. One factor is a power of 10, always. The other factor is a number greater than or equal to 1, but less than 10. So 2.56 to the times 10 to the 5th is correctly written in scientific notation, but 25.6 times 10 to the 4th is not, because that first number has to be equal to or greater than 1, but less than 10. So, let's change these each to scientific notation. So, what number am I going to start with on this? 3.7 times 10 to the, well, if I had the 0.7 here, how many decimal places would I need to move it? Try again? Try again?
8.
It's 8. Right, you got to move it past the first 2 and then the next 6, so times 10 to the 8th. All right, what's the first number here going to be?
4.871.
4.871 times 10 to what power? Yeah, I think that's right. 3, 6, 9, 10. Yep.
Oh. 3.7065.
Yeah, you have to include all of those. 3.7065 times 10 to what power? Oh, sorry, this one was supposed to be 10, wasn't it?
Yes.
My fault. Yeah, this is 9. Then we get into some where it gets a little bit more difficult. Like this one. You're like, okay, it can't be 25.6. It's got to be a number that's less than 10. So it's got to be 2.56. The question is, does this get bigger by 1 because we move the decimal place one place, or is it going to get smaller by 1? And what I always think about when I'm doing this is, did this first number get bigger or smaller? Smaller. So my exponent needs to get bigger. That's 2.56 times 10 to the fifth. What's the problem we have here?
There's no exponent.
Yeah, it's supposed to be something times 10 to a power, so it's 10.46 times 10 to the second power, because 100 is 10 to the second. Again, the exponent is how many zeros there are in that power of 10. And the problem here is this first number needs to be 1 or larger. So what am I going to make that? 9.3 times, I had 10 to the 8th. Did this number get bigger or smaller? Larger. So the exponent needs to get smaller. So 10 to the 7th.
Are we gonna have a test on that?
Pardon?
Are we gonna have a test on that?
On this stuff? Yeah. Yes.